we left off and you guys were filling in these charts. Filling in these charts. Okay, so we'll go over a couple of them just as a review. So we learned about standard angles and the fact that we have our 4 quadrants starting in the top right. Okay, we start counting quadrant 1, quadrant 2, quadrant 3, quadrant 4. And I reminded you that this is a heavy unit for labeling things. So the expectation is, yes, you put all these things on each chart every single time. Okay. This one said that so we learned about our standard angles, right? Where our initial arm is starting at the origin, 0, 0, and that goes along the positive x-axis. And then our terminal arm ends up in one of the 4 quadrants. Okay. And we also, combined with that, we learned about something called the reference angle. Okay, and the reference angle is always from the x-axis down to the terminal arm or up to the terminal arm. So in this one, we would have started with, okay, our initial arm on the x-axis, the positive x-axis, and we want a reference angle of 60 degrees in the 4th quadrant. So down here, you would have done something that would look like a reference angle of 60 degrees down here. Okay, and then recognizing that the standard angle, okay, is going to be 360 minus the reference angle, which gave you 300 degrees for your standard angle. Okay, hopefully that was all straightforward. Okay. What we're going to be continuing on with today is when we do our reference angle, okay, it's technically like a reference triangle. So we're going to be like adding in the x and y coordinates because we're on a Cartesian plane. Okay, so last time we talked about trigonometry, right, I said we're going to be substituting, instead of using a squared plus b squared equals c squared for our Pythagorean theorem, we're going to be using x and y and r. Okay, and you might think r, that's kind of a weird one to put in there. Well, r stands for radius because we're going to be doing what's called a unit circle. And so the r part is the part that is actually going to be on the unit circle. Okay, and then our x and y coordinates for that. All right. Did you guys actually like fill this all out? Okay, any questions about those? Like I thought that was, so this one, okay, this one just did the opposite. They gave you the standard angle. We'll just do this one real quick, just to make sure. They gave you the standard angle of 245. I cannot write and talk and think at the same time. Okay, so 245 would be over here. Okay, so well, let's get my standard angle in there. So we know that that was 245, and when you do your reference angle, okay, reference angle again, always coming down off of the x-axis, and this, we said we were in quadrant 3, and we ended up saying our reference angle would be the 245 subtract 180, which gives us 65 degrees. Okay. Hopefully that's awesome. Okay, so we are continuing on. So did you notice that when we're in quadrant 1, the standard angle and the reference angle are exactly the same? Okay, so for example, right, this would be your standard angle. This is also your reference angle. So only in quadrant 1 will the standard angle and the reference angle be exactly the same. In all the other quadrants, right, you'll have to do the 180 subtract the reference angle. Okay, you'll have to do 180 plus the reference angle, And then down here, you'll do 360, subtract the reference angle in order to get those. So you can just kind of remind yourself that for this one, this is your standard angle, this is your reference angle. And so you can see how to get those at your 180. Look. Did you sign in or were you always here? I was writing myself. Okay, so I'll just have to go back because I marked you absent. I didn't know. Let me do that. Okay, so for the next one, they're going to give you determine the standard position with a reference angle if it falls in the following quadrant. So the reference angle is the same, 60 degrees in all 4 quadrants. Just to make sure, draw a diagram, make sure that, okay, you're like just really, again, muscle memory, being able to draw your reference angle. I'm surprised sometimes, right, our brains kind of go mushy, and sometimes sometimes we will draw the reference angle like next to the y-axis instead of the x-axis. So we want to make sure that we don't do that. Okay. So you should be getting, okay, standard angle is equal to your reference angle. So 60 degrees. Standard angle is equal to 180 minus your reference angle. So we're at 120. Standard angle is equal to 180 plus your reference angle. Okay, so that's what, 240. Okay, and here our standard angle is equal to 360 minus our reference angle. Give us 300 degrees. And those. Okay. Now we're going to get to the x and y's that I was promising and plotting some points. Okay. So given the point, -4, -5, draw the angle in standard position. And then we're going to determine the reference angle. And we're also going to determine what the angle is in standard position. So first we're going to plot it. 2, 3, -4, 2, 3, 4, 5. Okay, so you guys recognize that these are your x and your y values. Yes. Oh, yep, you're right. I even wrote it -5, but I totally plotted it like not -5. 1, 2, 3, 4. Thank you. All right, let's try that again. -4, -5. Let's get it in the right quadrant. All right, so when you're drawing this, okay, I want you guys to recognize that x is -4, right? Because you went 4 units to the left. Your y here is -5 because you went 5 units down. Okay, and then if we connect the dots, okay, we have our reference angle here. Okay, now we're going to go back to grade 10 trig. Right, now we can use our SOHCAHTOA in order to find out the reference angle. Because, right, if we were to label this, this is our opposite side, this is our adjacent side, and this is our hypotenuse. Yeah. Okay, so what trig ratio would we use in this example? Tan, thank you. Okay, so don't forget tan is equal to opposite over adjacent. So what tan of my reference angle is going to equal -5 over -4. You're going to bring it, okay, calculators, remember, just double check that they're in degree mode. Otherwise, you're going to be very sad when it comes to writing down your answers. Okay, so in degree mode, oh, before we get there, Just a reminder. Okay, this is where you do the inverse tan. Okay. So our reference angle is inverse tan. Oh, don't want it there. I need to look at what it's got first. Okay, let's try this again. Inverse tan. 5 divided by 4. Okay, did you get 51.3 degrees? Let's do it to the nearest degree. So let's round it to 51. Okay, nearest degree is fine, guys. Okay, so when they give you points on a coordinate, this is what you need to do. You need to draw the triangle. You need to use X and Y, okay, and use your SOHCAHTOA, right, either your tan, sine, or cos. And now that you know that it's in quadrant 3, okay, what is your standard angle? Okay, your standard angle is 180 plus your reference angle. So 180 plus 51. Okay, so we should be sitting at 231 degrees. Sometimes I'm so excited to do, okay, get right into it that I didn't even label, okay, my graph, and I need to. Okay, guys, do a quick calculator check. On your calculator, okay, I want you to go tan 51 equals, okay, tan 51. You should get a decimal, 1.234, like this decimal, right? Okay, then I want you to do tan 231. Okay, you should get the same thing. So the reference angle, okay, is equal, like the value of it is equal to the standard angle. So the reason why we're doing this is because your calculator is limited. It cannot tell you what quadrant you are in. Okay, that's why we had to introduce this whole system of reference angles, because if you were just to inverse tan 1.23, it would give you 51. There's nothing that you could do to make your calculator, if you inverse tan 1.23, to get you to the 231. It just can't do it. Okay, so that's why I'm going to teach you some strategies of, right, using your calculator, but like figuring out the quadrants so that you can do, that's why we had to do reference angles and standard angles and everything, because your calculator, there's no way to input like where you are in it in order for you to give it back. Your calculator is always going to give it back to you in quadrant 1. Okay, and then it's up to you to put it into the right quadrant. Do this step here, okay, where depending on what quadrant you're in order to figure out your standard angle, okay? So let's take a look. Okay. Let's have you guys do one. There's one already in your notes. Okay, so here's a new point, -6, +3. So draw that out, determine the reference angle, and then find the standard, the angle in the standard position. All right, so -6. And this time we are going up. Okay, because I told you sine, hopefully you guys figured out that to do so, you would need the hypotenuse. Okay, so we're going to use our new x squared plus y squared equals r squared. Okay, so guys, when you do this, yes, you have to show me the extraneous root. Yes, you have to simplify your answer. Okay, and then I told you to use sine, which is opposite over hypotenuse. Okay, guys, if I were going to, okay, again, because we're growing up from grade 10. So grade 10, we did this. Sine theta is equal to opposite over hypotenuse, okay, which is still true, okay, but what would I use if I wanted to use my coordinate letters that we introduced? So what is my opposite for sine? Yeah, it's our y, okay. What's my hypotenuse? What did we rename it? R, okay. We're going to start using, when we talk about sine, we're going to start using y over r instead of opposite over hypotenuse. They're the same thing. You can still call that in your brain, but we're going to start writing y over r. Okay, so what's cos going to be? Instead of adjacent over hypotenuse, it's going to be x over r. Yeah, and then tan, instead of opposite over adjacent, it's going to be y over r. Yeah. Okay, you see where we're going? Okay, so when we do, and this is actually, anybody taking physics 20 right now? Okay, some of you are. So have you guys already gotten to the, like where you're doing catapults and like projectile, you did that already? Okay, and when you have to like split them up, right, into like their, into vectors, right? And there was like a x component and a y component. The y component was always the height, and the x component of your projectile was always the horizontal distance. And so when you did it, your vertical distance was always your sine, and then your horizontal distance, your x, always included cos. Okay, so that kind of like ties into what we're doing here. Right, so sine, okay, of our reference angle is equal to 3 over 3 root 5. Okay, however, we have to rationalize that. Okay, so we're going to multiply top and bottom by root 5. So you should have, okay, root 5 over 5. Okay, and so this is like what I'd want to see. Okay, nice, beautiful, exact numbers. Obviously, when you take the inverse sign of that, your calculator is going to convert it all the decimals for you to give you an awesome reference angle of, what did we get, 27? And then our standard angle is going to be 180, subtract the reference angle. So 180 degrees, subtract 27 degrees. You should have gotten 153 degrees. Okay? So now you can see, like, depending on the information that they give you, okay, sometimes you'll need to use sine instead of tan, or use cos instead of either of the other ones, right? Oh, I guess I could give you some time to do your homework so you don't have homework on a weekend. Okay, why don't you go ahead and grab your textbook. Let's do 5 all, 6AB, and 7 all, and any previous homework that you haven't already completed for trigonometry.